Hello everyone, my name is Anjanette Cash. I am a doctoral student at the California Intercontinental University. Today I will be conducting a chi-square test of independence. Here's our agenda today. We'll be going over some definitions and tools, Cramer's V interpretation table, 3 chi-square of independence test examples. We will also look at some takeaways for using chi-square of independence. And last, I will take any questions you may have. Here are some definitions and tools. Chi-square of independence is a tool used for testing hypotheses when the variables are nominal. The formula for chi-square of independence is x over 2. Cramer's V is a strength test used to test the data when significant chi-square result has been obtained. The PSPP tool was used to calculate the chi-square of independence. Here we have the table of Cramer's V interpretation. The first column lists the strength and association of Cramer's V, ranging from 0.00 to 1.00. The second column is the interpretation for the value. For example, if Cramer's V result was 0.33, it would be interpreted as a strong relationship. Here's our first hypothesis test. The following chi-square test of independence was conducted for the number of cars and the number of defaults. Our null hypothesis states there is no relationship between the number of cars and the number of defaults. Our alternative hypothesis states there is a relationship between the number of cars and the number of defaults. The chi-square statistics and its p-value were calculated using PSPP, assuming A equals 0.05. No relationship emerged from the calculations of chi-square with 6 degrees of freedom in 150 cases with a chi-square value of 6.68, p-value of 0.15. A second hypothesis test. The following chi-square test of independence was conducted for light, comfort, and number of defaults. Our null hypothesis states there is a relationship between light, comfort, and number of defaults. Our alternative hypothesis states there is a relationship between light, comfort, and number of defaults. The chi-square statistics and its p-value were calculated using PSPP, assuming A equals 0.05. No relationship emerged from the calculation of chi-square, 6 degrees of freedom equals 150 cases with a chi-square value of 6.68, a p-value of 0.15. Here's our third and last hypothesis test. The following chi-square test of independence was conducted for the number of cars and light comfort. A null hypothesis states there is no relationship between the number of cars and light comfort. Our alternative hypothesis states there is a relationship between the number of cars and light comfort. The chi-square statistics and its p-value were calculated using PSPP, assuming A equals 0.05. A relationship emerged from the calculations conducted for chi-square with 9 degrees of freedom, 150 case, which equals a chi-square value of 450, a p-value of 0.00, and a Cramer's V value of 1.00. Cramer's V indicated a perfect symmetric relationship. Here are some takeaways from today's presentation. Remember, Cramer's V tell us how strong the relationship is. If we reject the null, then we follow Cramer's V. Chi-square test of independence assumes that an individual observations are independent. When using the PSPP tool, Pearson chi-square is the same as chi-square. This concludes the presentation. I would like to thank you for watching. Please use the comment box for any questions you may have. And again, thank you.